Hey everybody, welcome to this webinar hosted by JetBrains. I'm your host, Nafiel Islam, developer advocate at JetBrains, and today we have Craig Kerstiens, the Postgres man himself, who is going to be telling you a little bit about how to have fun with Postgres. So just to let you know a little bit about Craig, he's been in the Postgres world for a very long time. He was at Heroku, then eventually Citus, which was acquired by Microsoft, and now he's at Crunchy Data, where he's head of product over there. So without much further ado, Craig.
Cool, thanks. So I'm going to spend a lot of time on Postgres today, a little bit of time on Python, and mostly hope to kind of whet your appetite to some crazy things you could do with Postgres and Python together, Python directly in the database. Trust me, I'll get to that to the tail end, and my hope there is people end up nice and excited, but want to spend the bulk of the time actually up front on Postgres. I think we just covered a whole bunch of this. Currently, I run product at Crunchy Data. We basically are the Postgres people. You can think of us as what Red Hat is to Linux. We are to Postgres. We employ about, I think it's 11 now major contributors or committers to Postgres. And I, for better or worse, have just been doing Postgres for a long time. Way back in the day, I actually launched the Python support at Heroku, so Python is very much near and dear to my heart. But I spend kind of most of my time over on the Postgres world of things, kind of in that nexus between app devs and databases. And I was at a conference about 8 years ago, and at one of the speakers' dinners, and someone was like, hey, it's app devs. We kind of cargo cult things, right? Like we always say, like, oh, I'm well thought out in my opinions and my basis of like why I chose this, why I chose React or Angular, and there's all these reasons. But we were kind of having this very transparent conversation of like, I totally get into those arguments, but I also cargo cult just like everyone else. And the other speaker said, take for example Postgres. Why is it any better than MySQL or Mongo, or why would I use it at all? Like it's just a database. And half the table knew me really well and got kind of quiet and just looked over at me. And I listed off a bunch of reasons just off the top of my head. And if you're not familiar with some of this functionality, I would encourage you to go kind of dig into each of it. Like each piece of this is really, really powerful in Postgres. And my default stack, anytime I start something, it's usually Django and Postgres. And I joke sometimes on Twitter that this isn't the shiny new technology. This is that I'm going to build an app and make money and just go create value. And I start with Postgres, and it goes a really, really, really long way for me. I don't have to go and run and maintain 10 systems. Postgres can go really far. And there's a lot of features in here that some of them you just get and don't even realize it. Transactional DDL is a huge one where if you're running like a new column addition and it fails midway, it's actually going to roll it back. Whereas certain other databases will leave you in a broken state where like half the table has the data and half of it does not. Data types, we're going to talk about that a little later. Super exciting, really rich. I encourage people to really, really leverage the data types inside the database. I was talking with someone, I think it was last week, and they were talking to all these app devs, and they literally put everything in a text field, every single thing in the database, and do all this conversion back and forth between. And I just banged my head against the wall. The data types are really, really powerful, and it's worth taking advantage of them. Listen Notify is super cool. This is pub sub inside your database. So if you want to have like a queue that notifies when something happens, really, really, really sweet. Partitioning, time series has gotten better and better. It keeps getting better in Postgres. There's also extensions for this. Foreign data wrappers are really, really sweet. You can query from inside Postgres to other systems. So like I can map Redis as if it's a table inside my Postgres database and query and join on that. The Postgres FDW is wonderful. It'll actually push down like your where clauses and that sort of thing. So you're not returning an entire table. So if you have two completely different Postgres instances and want to join them, well, you can just map those virtual tables and not have to run an ETL job. I'll cover some of these more in just a minute. But I kind of want to really, really hit on that point that Postgres has a whole lot in the box. And I encourage most people that haven't dug into it and that just think, oh, I'm just going to put data in and get data out. And yeah, I'm using Postgres, but I'm not using anything special about it. You're kind of missing out. DHH of Ruby on Rails famously said, like, the database is just a dumb hash. Like, that's what it's there for. You just put data in, you get data out, and that's it. And I have so many issues with this thought when I see all this functionality, and yet we're going to go and rebuild it and rewrite it all from scratch in something else, or build ETL pipelines and jobs to do all of this. So, you know, I just don't get it, right? So you've got arrays in your database. Cool. So if I'm using arrays in my Python application, why not have them in the database? You could have them as a different column or whatever, or a table, and join them. But also, like, a really common one is if I'm doing like a blog and I want to have tags for my blogs. Like, tags is a perfect thing as an array. You don't need to join that to another table or break that out and have a relationship there. JSON, we'll get into this more later, but we've had JSON support in Postgres for 10 years now. Like, I wrote one of the early blog posts about JSON in my Postgres database. And, you know, there's no reason that it can't work just like a NoSQL database, and you get all the transactional guarantees. I mentioned that I always start with Postgres, and I try to do everything with Postgres I can before I add another system. And it's not that Postgres is the best at everything. I kind of give it like a B grade on a lot of things, like full text search. I give it a B grade. It's not quite at what Elastic is, but if I don't have to maintain Elastic and Postgres, I'm maintaining one less system. So it's really nice as soon as I need full text search to simplify just a little bit more. It's pretty well regarded as the richest geospatial open source database. And depending on who you talk to, the only other really kind of geospatial relational database that competes is Oracle. And, you know, it has its own price tag. And some people will actually say Postgres is more feature rich. So I encourage you to go and dig into each of these things. Common table expressions are super useful. Common table expressions will allow you to do things like recursive queries, but also you can break your queries up. I wish we were live and there was everyone in the room and I could ask you to raise your hands of how many people like writing SQL. I usually do this and I get about, in a room of 100, I get 10 hands of 10 people that like writing SQL. Then I ask how many people like reading other people's SQL, and the hands drop to like 1. And usually that person, hey, we need to go to some counseling together, because like SQL is usually a horrible language. Common table expressions allow you to break it up to basically like inline views and write it almost as if I'm writing Python right there. Range types are great if you're doing anything with calendars. Pluggable storage is new in Postgres, where we had different storage backends. So a lot of really exciting stuff. If you're trying to do something and you're looking for another system and you're doing anything with data, I encourage you to go check out Postgres a little bit more. Can it do this? Can it work for me without more complexity? There's a really good chance it can, and it can do it really, really well. And so where we're eventually going to end up at today is taking a look at something that it really can do. And we'll get to the code in a little bit. So hang on for another half hour and we'll get to some of this and dissect it. But we can actually go and put Python with PL Python directly inside our database to do logic directly on the data where it resides. And in this case, we can have a full recommendation engine as a function directly inside Postgres. So this is all Python with pandas that hopefully people would recognize. And it's just a function that I can call now to get recommendations based on what's in my cart for a particular product. Pretty fun and exciting. And, when I first wrote this code, I was like, you should never do this in production. And the more I sit and think on it, it really depends on your use case, right? If you're, the other alternative to this is you ETL out your data every night using something like change data capture with Debezium into Kafka. You feed that into Spark to run your model. You feed that back into Postgres or Redis, so it's in a cache. And you're not going to be doing that in a real-time basis in most cases. And so you're maintaining, quite a few systems. So pretty exciting, the things that you can do. I think, Nifrul and I were talking earlier, and we swung too far. A lot of times people were like, hey, don't do anything smart in the database. There should be no intelligence. And we came from a world of Oracle and SAP where the entire app was coded as stored procedures. And it was just like, it's terrible. Like it's like you go and debug these things that are 30-year-old systems, and it's awful, right? You get paid $500 an hour to maintain COBOL, and that wasn't good. But we were talking, we've swung the other direction, right? Like now we're like, no, just put in the data and don't index it, don't do any logic on it, just put in the data, and I'm going to do all my logic somewhere else. And we've swung too far, and I think there's a medium somewhere in between that we're missing.
I completely agree with you. Just one thing that I'll say is what I love about Postgres is also the fact that it has foreign data wrappers, so it plays well with other technologies. It's not just, hey, this is our stuff, you can only use our stuff, and the stuff we say that's good, you can use it with other things as well. And by the way, this slide that you're seeing right now, this is Python inside of the Postgres database, which is just phenomenal in my opinion.
Yeah, it's one of those things. I think you bugged me 8 years ago at Heroku when I said, you're like, hey, can I get PL Python? And I said no, because we can't sandbox it. And I think we've done a few things at Crunchy to allow that to work. So Crunchy Bridge, you get PL Python because it's not a multi-tenant shared environment where you can escape and sandbox it out, but you get the full standard lib. And here you can actually see, we'll get to this later to not jump ahead to the really like the most fun stuff at the end, but hey, we're importing pandas inside of Postgres. My mind still just kind of pauses on that you can take Python and you don't have to work all in SQL. So I'm going to throw a lot at you. I'm going to have some queries. I'm going to walk through a lot. Going to spend a little bit more time for a few minutes on Postgres because I think it's worthwhile. So bear with me. You don't have to copy the queries. You can Google them, find them online. I think the biggest takeaway that I could give you is don't be afraid of the database. You don't have to be an expert at it. You shouldn't be. Like, you don't need to go get a PhD in databases and drill into MVCC to have a well-maintained, tuned database. But also, if you haven't looked at any of these things, your database is probably horribly tuned and unoptimized, and you're spending too much money on it and having performance issues, and you're trying to engineer around those in the performance in the application layer, where there's probably a really quick fix by just digging in. And literally, a lot of what we're going to walk through, I walk through this on a fresh database, and in 10, 15 minutes can tune up a Postgres database. If you're really good and quick and want to try to follow along, if you've got a local database, by all means, Google the queries and try to kind of follow along as I go. So the very first thing is connection management. For years, I had this debate with the Django core team about persistent connections in Postgres. And they're like, no, it doesn't take that long to get a connection. And then I actually showed where, on Heroku, grabbing a connection to a database. So every new request that comes into Django for years would grab a new connection to the database, run a query, return the data, and let go of the connection. Running that query was usually about 2 milliseconds, and grabbing the connection to the database was between 100 and 500 milliseconds. A lot of that you're doing is SSL TLS negotiation. And so they went and gave us persistent connections, where now when you boot up a Django web server, it's holding a bunch of connections. Now, the problem is Postgres isn't great at this. By default, Postgres is going to use about 10 megs per connection. Now, for those of you that read the Postgres mailing list and say, oh, no, but it's getting better. Yes, it's getting better in Postgres 14, which isn't out yet, and it's going to get better in Postgres 15. But I don't know that all of you are upgrading to Postgres 14 on day one. Regardless, having something like PG Bouncer helps. And what PG Bouncer does is it sits there and waits. It has its own pool of connections and waits for Django to run that begin and then start to run those queries. And So when I look at most applications, if you have 100 connections, 90 of those are idle, and they're just wasted. That's 90 times 10. That's a decent amount of resources you're just wasting sitting there doing nothing. And so one of the first things I'm going to do is come over here to a database that I'm running and just check out my connections. And you can see I've got one active connection that's doing something, and I've got 13 idle ones. If I were to put PG Bouncer on this database, it's going to basically have those 13 idle drop down to really to 2, maybe 3 that it's setting there maintaining its own pool. And I'm going to jump back and forth a little bit between DataGrip and PyCharm. I could do all of this in PyCharm. I personally like to have kind of my database scratch pad of these constant queries I run all the time. Just any new database I connect to. I like to, and we're going to walk through each of these gradually. Have this in my own scratch pad, but this could easily be right in PyCharm inside my entire Python application that I'm running this checkup regularly. And so if I swap back to Python or to my deck here for a minute. So that kind of falls into the start of the performance bucket. And performance on your Postgres database is a mystery for a lot of people, and it doesn't have to be. In really about 15 minutes, we can look at things like run that query for your connections. And if you see 30 idle connections, 40, 50, PG Bouncer is going to solve that for you. So I recommend installing PG Bouncer, looking at a server-side connection pooler, which is different from a connection pool in Django or SQL Alchemy. Those are actually making that idle worse. And so what I'm going to do is run through a bunch of these queries here in a minute around cache hit ratio, index usage, connection management, all these things. And really, these 6 queries are kind of like your database health check. And based on the results of each of them, you can know how well-tuned and performing your database is. The first one, just because I wanted to work in DuckTales, because I'm so happy that like the cartoons from my my childhood are coming back and my kids are enjoying them. So excited about this reboot on Disney Plus. But the general idea, number one thing I'm going to look at is my cache hit ratio. And this is the idea that Postgres is really good about serving recently accessed data from in memory. A lot of times when people are like, oh, I'm going to go put Redis in front of my Postgres, so I have a cache. Well, Postgres is caching things under the covers for you. It's already doing this. Now, if you're going and doing it manually and thinking you can do it better than Postgres, I kind of beg to differ and would say, like, no, you're probably just underutilized on the database or need to add some indexing. As soon as you go from 99% to something like 98, queries might start going from 1 and 2 milliseconds to 100 milliseconds. It's not like we went from 1 or 2 milliseconds to 4 or 5, because the difference is now we're suddenly going to disk so much more overall. And so let's go ahead and run through a bunch of these queries here, and I'll try to kind of highlight each of them as I go along. So the first one is the cache hit ratio that I just mentioned. And so we run this query against any database, any Postgres database, and you're going to get something like this, the times that we've read from heap and the times that we've had a hit. And you're going to get this ratio. And I almost could not be happier. I don't know that I've ever seen a database truly at 100%. This gets really, really, really close. 99.88%. So in this case, like, I'm great, I'm good, I don't need to do anything. If I saw this around 98%, I'd start to think about upgrading to a larger instance with more memory. And so really your cache hit is about data being served from memory. And if I'm down at 90, unless I'm doing something like a BI reporting app, right? I'm running a bunch of batch reports. I'm not doing a bunch of short web requests where it's give me user and like, let's do a checkout and, let's look up these products. If I'm doing really batch reporting where I'm getting hundreds of records at a time, then I might see that closer to an 80, 90. But your typical web app that's short requests, small records, you want it at 99. As soon as it gets to 98, 95, I'm going and just upgrading to a larger instance. It's the easiest way to scale databases. It really is. So indexes, I also want to take a look fresh from a really high level on my index hit rate. And so this is going to return every table in my database. So we can see over here, we've got our impressions, our clicks, our campaigns. So in this case, I've simulated an ad network. And you can see I've got, is that 2 million records? So it's a reasonable sized database. This is nothing massive. This is not, web scale, but it's reasonable enough. And you can see that 20% of my queries here use an index. On clicks, 0%. So what this tells me right out of the gate is probably could benefit from some indexing. Unless I'm trying to grab, millions of clicks at a time, which I'm usually not. Maybe I'm looking at a few quick ones here or there, or maybe it is for batch reporting, and that's totally fine. But I kind of want to get some sense of, I got a lot of records here, but I'm never using indexes. What can I do? I think it was 5 years ago, I wrote a joke tweet about the best way to make your database faster is to index everything. And so don't actually go do this. But this query, which was able to fit into a tweet, will give me the commands to run and create an index on every single every single column on every single table in my database. You probably don't want to do this. Your writes will slow to a crawl. Every new index you add slows down writes to your database. So you've always got this dichotomy and trade-off of, oh, fast reads, but you get slower writes. Oh, you have no indexes. Writes are going to be really fast, but reads are going to be slow. So you want to have the right balance here of what are the keys you're looking up on and that sort of thing. And I wrote this as a joke, and you'll have to forgive me because I thought I had it in here and I realized 30 minutes ago I didn't. If you search for unused indexes in Postgres, you'll get a query that'll show you all the indexes you have that have never been used. And so what I could do here is go and create an index on every column, come in tomorrow and drop every index that has never been used by my application. And now I've actually got a reasonably tuned, I give this as a crazy science project. I wouldn't do this live in production, but on staging, maybe it's not a terrible idea overall. PG stat statements. If you don't have it installed, please install it. Create extension PG stat statements. My colleague Peter Gagan authored it years ago. He was my colleague at Heroku, my colleague at Crunchy, and it's wonderful. If you do not have this installed in your database, please go install it right now. I think Heroku auto installs it for you. RDS does not. Azure Postgres does not. Google Cloud SQL does not. Crunchy Bridge does. So please just go install this. What it's going to do is record every query that runs against your database. You're going to have this system view here for PG stat statements, and you can see, all this stuff. You can see things like min planning time, max planning time, the mean, the standard deviation, stuff that I've got to go and poke open the PostgreSQL docs to understand what does this mean? What is shared blocks hit, read, dirty versus local blocks versus temporary blocks? There's a lot in here, and you can go really deep. But you can also go really basic. And so if I run this query against any database with PG stat statements, what I'm going to get is the sorted by the total time consumed against the database. So in this case, I forget if this is minutes or milliseconds. This is my small demo database, so it's not crazy. But this is the query that's consumed the most time against my database. And you can see I wanted something to jump out here that was pretty bad, right? On average, this consumes 1,440 seconds when it runs. So I think this is like a sleep several hours to highlight how bad this could be, right? You can also see other queries that I'm running here. And you can see where I've kind of gamed it, right, with my sleep in here that I'm sleeping for a few seconds to have these appear bad. Some of my other ones, right, are in the milliseconds, right? My inserts here is 0.02 milliseconds. This is great. This really lightweight select is fine. And so what I'm doing here is I'm starting at this total time right here and saying, okay, I've had 76 minutes against my database just consumed by this query. And it takes on average this long. For a lot of queries, things like, this insert or a basic select, select star from user or email like this, that's going to return 1 or 2 records. And I just know from what I know about Postgres and returning things from memory that should be a 1 to 2 millisecond query, if not faster. So when I see things in the hundreds of milliseconds, like this one, this 685 millisecond query right here, where it looks like I'm trying to get some kind of the name of an ad and how much we consumed of it, I can probably really benefit from an index on the ad ID and something else there. And that 685 milliseconds on average, I can bring down probably not to just 60 milliseconds, but to 6 milliseconds and drop that 9 down to, a full orders of magnitude. So without knowing anything about the application, I didn't have to look at any of the ORM calls or my logs. I can come in here and start to add 3 or 4 or 5 indexes that are going to add a huge performance boost to my database. Finally, I'm going to take a look at bloat. This super simple, basic, naive query here is going to return something a little more readable. Don't be scared when you see this query. It's all quite safe. And it's what it's going to show is, so Postgres under the covers, it's a giant append-only log. When you write a record, when you do an insert, yes, it writes a new record. When you do an update, what it does is it does an insert, and it marks the old record as dirty, as deleted, as gone. When you do a delete, it just marks it as dirtied, and then later it comes through and vacuums that. It says, oh, let's clean up these old pages, and now we can put new data on those pages. It doesn't necessarily decrease your storage. It says, oh, Postgres can now go put new records in there. And Postgres is pretty good at auto vacuum about going through and keeping up with that. But sometimes when you have a really busy table and auto vacuum can't keep up, you need to come in and tune it. And so here what you can see is this table bloat of 3.1, what it means is I have 3 times as much data that is dirtied and deleted as I do actual data. So I'm actually wasting a whole bunch of storage. You can see the wasted bytes. We could pretty this up and print it out as actual megabytes if we wanted to. But this is an area where, I need to come in here and tweak my vacuum strategy to be able to keep up a little bit here. These are the queries I just keep. All of these 5 queries and unused indexes that any new database. If you haven't run any of these against your database, I really encourage you now, after this talk, if you have questions on it, tweet at me. I would love to, chat of, what's this mean? What's that mean, right? Email me. Love to kind of drill into these of, here's how to understand performance at a really, really high level.
So Craig, just 2 questions. One is you showed us a lot of really cool queries over there. Are any of these going to be available on GitHub for people to just clone and check them out?
Sorry, as I took a sip of drink there. Yeah, absolutely. You can find them on GitHub. There's a lot of blog posts, and I'll have some links later where you can go. If you Google any of these queries, and I'll hit on some of them right here. If you Google cache hit Postgres, you'll find the query. You may find it in a GitHub repo. You may find it on a blog post. I tend to like the blog posts because they also tell you how to understand them. A lot of these, when you see, index hit rate, right? Well, if I go back over here, what's good, what's bad on this, right? How do I dissect this? And so that's where I think a lot of times, the extra blog content helps. There may be a GitHub repo that has a lot of this already. If so, I'll see that we can, do some follow-up on that and provide that GitHub repo. So all of these are easy to find. They're not secret mysteries.
The second question is, what version of Postgres are you using?
So right now I'm on Postgres 13. Almost all of these queries will work going back to Postgres, 9.2, 9.3, 9.4. Occasionally there might be slight differences in them. And so if you get an error, you might need to tweak it. And one example is, if I come back over here, on an older version of PG stat statements, there is no total exec time. It's just exec time. So on an older version of PG stat statements, it may look like this. PG stat statements now has even more data. So it has like planning time and execution time, right? And so I want not just how long it took to do the planning, which is how long Postgres takes to like figure out how it's going to run this query. I want to know how long it actually ran start to finish, right? The planning time and actually executing the query.
Right. And last question before you head into the next part of your presentation.
Cool.
What do you think about running Postgres on Kubernetes? I just think about that and I find it to be a very scary thing, but you know how to do this. So what do you think?
Yeah. So I wouldn't go and put Postgres inside Kubernetes because you want to. I would go and say, oh, if you're using Kubernetes and standardizing for other things, and like Kubernetes isn't going to give Postgres magical superpowers. It's not going to change anything about Postgres. It's still Postgres under the covers. I talked to a lot of people who are like, oh, no, I would never do that because I don't want to deal with all that complexity. And like, okay, cool. How are you managing all your app, right? And you can also just connect to Postgres from anywhere. At the same time, I talk to a lot of large enterprises, and it's a ton of enterprises that do this. And at Crunchy, I think we have the most starred Postgres operator, and we support a lot of customers on, several top banks and IBM and SAS. You use our Postgres operator and Crunchy customers. And what they've done is said, we've standardized on Kubernetes. Everything deploys through this, and we're going to run and manage everything that way, right? And Postgres absolutely works that way. It's just a question of, I wouldn't say, oh, you should use Postgres on Kubernetes or you shouldn't. The question is, have you chosen to standardize on Kubernetes for whatever business exec reason, or I don't want to have to learn a new tool, or I don't want different ways to maintain things, right? I don't want Chef here and Ansible here and this on bare metal and this on Kubernetes. If you standardize, and there's good reasons for that, great, run Postgres in Kubernetes. And if you decide I don't want to, I want to run these pieces, but my stateful services, I want someone like Crunchy Bridge, our database as a service, or RDS, just plug in your database URL to it and connect. It's really not a Kubernetes is good or bad for databases. It's why are you choosing Kubernetes? And then do you want your database in Kubernetes or not? That's my thought process. I don't know if that answered it well enough for you or not. I'd be curious how your take on that.
I mean, honestly, I just think that plus you have the kind of expertise to do it, because we're talking about, it's not a stateless service. It's an actual database that has to manage state. So
yeah, definitely. If you do have the in-house expertise, right? If you do have a system of dedicated DBAs, it is different. Like you're basically kind of pinning pods to certain places and pod affinity so that things don't shut down and reboot. It's not the same as your app. And so you've got to have a little bit of knowledge there. And if not, you're in for a world of hurt. But we at Crunchy support a whole bunch of people running our Postgres operator on Kubernetes. So if you ever have questions on that, we've got a whole team of people very, very happy to chat. And hey, we've lived through some battle scars, but we've also got people, embedding this in virtual appliances and deploying to hundreds and thousands of customers. And yeah, it's Postgres and Kubernetes and working, and you've got backups and HA and monitoring and all that, just like you would on bare metal. So it's very doable. The question is it right for you? And like that's all a personal question, right?
Yeah, and we have another question. Does PG underscore stat statements, so basically PG stat, purge itself after a while? From what I understand, these are all views, right? So there's not really much to purge.
So
and,
it'll keep all of history by default. So it's a view on underlying system tables. But what you can do is do a PG stat statements reset. So there's a function for resetting the stats. I very, very, very seldom do this. I will do this maybe after a really big upgrade, maybe after I run and create a bunch of indexes. But I also won't necessarily do it right away on day one. I may wait to see, do these queries get a little bit better and a little bit better? So you should reset when you're trying to do bigger, more invasive things, not every single deploy. Like look and see are things improving and the average going down, right? I'm going to look at that combination of what's my average time as well as my total time.
Right. And will PG statements add any overheads to queries in production? I don't think so. These are just, you know,
it is
underlying.
so minimal. Yes, like technically, yes, there is overhead. You will, the first query you optimize, you've gained that overhead back. It is so negligible that there's no, like,
that's a good way of putting it.
The technical answer is yes. The reality is like there's not a, like it's a fraction of a millisecond, if that, of overhead. So please, if it's not installed, go install it. When you have that bad day on performance debugging and you're to say, oh, I wish I had this. Now I'm going to enable it. Oh, crap. Now I've got to do the restart. Now I've got to do this. And now I've got to wait a week to get the data to figure out the performance problem. I'm just sad every time I show up to a database and it's not there. So you can thank me later. Just enable it if you haven't. It's so useful.
Yeah, I mean, the thing is, I took it for granted. I thought this thing just came with it because it was already in Heroku. And my first experience with production grade Postgres was with Heroku, which is exactly how I met you and complained about how there was no Python support.
Well,
so yeah,
let me keep rolling so we can get to the fun stuff.
Exactly. Well, all right.
Cool.
Let's get onto the fun stuff.
This has been up for a minute or two. You know, cache hit ratio, just summary. I'm looking at 99%. Index hit ratio, I'm looking at 95% on most tables over 10,000 rows. The rest of these things I'm coming in and kind of checking, you know, every 3 months, not all the time. You know, PG stat statements, really, I'm looking at it about monthly, not weekly for most cases. Just set a calendar reminder. It's literally 10, 15 minutes and you can tune a whole lot in 10, 15 minutes, save a lot of money, give a better performance experience, all of that really, really easily. All right, I'm gonna try to fly through this because I want to get to some of the fun of PL Python. So data types are really awesome. I mentioned earlier, I talked to someone that they were talking to someone that was just using text types everywhere. I think this is a little less common, especially if you're using Django or SQL Alchemy, you're using these types a little bit more. Timestamp with time zone is really useful. It'll allow you to, like, when the database is over in Eastern time and I'm querying from like Pacific because it knows my local session, it'll translate those times for me. Really, really handy. Arrays, I already mentioned. Range types are so useful. They will allow you to do a from and a to. If you're doing calendaring, please don't have a model that is a from one and then a to one. Have them all in the same one. Django supports a range type where you can have from and to. And what this means is you can have where, oh, if you're doing a college scheduling application, you can make sure that I'm not in two classes that overlap times. This is actually quite frustrating and annoying to do. And I'm sure people have written all sorts of Python Go to handle that logic. And you can get race condition there because of how transactions work. Postgres will allow you to enforce that constraint at the database level. JSON, JSONB. So they are absolutely awesome, both of them. First we had JSON, then we got JSONB. My colleague jokes that the B in JSONB stands for better. It keeps getting better. I'll get to that in just a minute. So a disclaimer, I wrote a blog post 10 years ago talking about JSON and Postgres, and we totally cheated, and it was absolutely marketing. And it was, pulling a fast one because all we did was validate that it was valid JSON. We parsed the text as it came in and said it was JSON and put it into your Postgres database as a JSON type, but it was just a text field. It preserves all the white space. There's no indexing. It's really good for logs and audits records. If you want to just insert a bunch of JSON and you're never going to query it, it's actually great for that. Most of the time when you use JSON, you want to query it, right? You want to query on certain operators and other things. So the B, is actually for binary. It's a binary representation on disk. It doesn't preserve your white space, but you can use gen indexes on it, which will index most of your columns and keys within that JSON. And now it'll automatically use those indexes depending on which operator you use. And so I mentioned JSON keeps getting better. I could not be more excited about this in Postgres 14. So right now you have to use this weird kind of caret operator to traverse your JSON, and the caret with like two greater than signs or less than signs brings that out as text. Otherwise, it's a quoted neon kind of color because it doesn't know how to escape it. This is a horrible, horrible syntax. It's not how you expect to work with it. It's specific to SQL, and there's reasons for that. And with Postgres 14, we now have a much more what I would call Pythonic way of like just operating with our JSON in our database. Now, this style of format here isn't necessarily going to use indexes, but I'm not usually writing a ton of raw queries like this in my application most of the time. I'm using various operators. I'm working through the ORM that's going to do special things. So it's really welcome that I'm okay with it not using indexes when I'm doing a when-off kind of lookup for all of the neon yellow shirts that exist in the product catalog. Postgres 14 is not out yet. It's probably in a month or two, but this is such a welcome change. So I'm upgrading just because of this. Super stoked. And JSON keeps getting better and better in Postgres. So don't be shy and think, it's a Postgres database. We can't do other things in it. All right, let me try to get into a little bit more Python here. This is a small pain for me. So Heroku, we codified a lot of the Heroku core principles. I think it was like 7-8 years ago in something called the 12-factor app. And this was like the ethos of Heroku, like deeply thought out, like beliefs and structure and why we build apps the way we do. And when I look at most of the Python docs as a starting point, you see this where it's, here's your connection string, host, database, whatever. And a lot of times I'm hard coding in secrets and it's a bad pattern. PsychoPG2 has had this support for, because under the covers, it uses libpq, the Postgres driver, for actually just parsing a DSN, which is just kind of looks like a URL, but it's basically kind of a thing that you can parse where it's the protocol. Here's username, password, at the host name, port, database name. And you can simply just pass this into any PsychoPG2 connection and connect to your database. And so over here, like I'm going to read this from my environment variable. So very 12-factor. I'm going to set my database URL as my environment variable. And I'm just going to connect right here by just saying, database URL and setting my SSL mode to true. It pains me that the Python docs don't kind of follow this approach more. And you look at all the PsychoPG docs and here's how to connect with this long way. And you copy and paste this. Start using a DSN. Heroku will give you one. Crunchy will give you one. I think RDS will give you one. It's just a better experience overall. You can pass it directly into pSQL if you want. It's really, really portable and a better way to use things. So it's small pet peeve there. All right. So JSON and Django. I've mentioned JSONB. I've talked a lot about the Postgres stuff. Django is going to take care of this pretty well for you. I'm so happy to have this within Django now that you've got all these this Postgres contrib here, and you've got a number of data types. And take a look at these. If you're doing anything in your application, when you add a new model and it's not a basic text field, or you're kind of doing some joins and adding a related one, take a look and see if any of these would be the value. So I mentioned arrays. I mentioned JSON and range types. There's also CI text, which is case insensitive text. I've seen applications migrate over from MySQL that had hidden needs for case insensitive text if you're searching for names or emails or something like that. HStore was kind of the precursor to JSON. It was a key value store inside Postgres. Some people still use it. It's not bad. Not forgetting SQL Alchemy. I really like SQL Alchemy. I like it better as an ORM, but I find myself using Django for the full stack. But if I'm just using the ORM, SQL Alchemy is really great. and you've got the same set of arrays and JSON and range types. Really, 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 really sweet. So back to JSON a little bit. Gen indexes are your friend. If you have a JSONB data type, you probably want to just add a gen index onto it. Postgres actually has 5 different index types. If you do just create index, it's kind of the standard B-tree index that you learned about in CS school. If you've got a CS degree, that's probably the index you first learned. Gen is generalized inverted index, which will index every value within a single column. So if you have arrays or full text search, you may want gen indexes. Gist is common for when you have values that can kind of overlap between rows. So full text search is common there, where you've got like parts of a sentence and speech. You've also got polygons. If you're doing geospatial stuff, you'll see a lot of gist indexes. Both spgist and bren are common around really, really large tables that naturally group together. So things like zip codes or phone numbers, where you've got kind of a prefix, then another kind of prefix, and then the other part of the number, that naturally cluster together. And I'm talking, hundreds of millions, billions of records, really useful. So one caveat on gen. That operator that I showed before generally won't work with gen indexes. You have to use this contains operator. I expect maybe in Postgres 15, this gets a little bit better. So just kind of be careful. Run and explain on your queries. Take a look at things. Know that, hey, you've added the index, but then pay attention again to PG stat statements, right? And our index hit rate. Are we using those indexes or not? All right. So if we were all in person, I'd ask again, how many of you actually like writing SQL? I do. I'm really strange. It's a powerful language, but I don't love reading most of the other SQL that I like from other people. We were talking earlier, right? We swung too far. Like, the database isn't a dumb hash. Hopefully, if someone now asks you, why you pick Postgres, hopefully everyone has a good answer and can rattle off at least a couple things, right? And let's, if we were to do this in procedural stuff inside Postgres, and let's start to add some logic, well, now we're working with PL/PG/SQL, which truly is a horrible language. Like, it's not beautiful, it's not pretty. But the other option, right, is that we call out to Python, we return all this data, we wait for it, we do some work on it, and we feed it back into the database. And there's a lot of latency here, right? Not necessarily in just the calling out to the database, but it's kind of this long ETL pipeline where it's not real time. As much as we want to try, and if we do make it real time, we've got 3 or 4 or 5 systems that we're getting paged if they go down. And so what if all this could be in Python, right? Like, why not? It's really, I think, an exciting idea of, well, I'm not going to go put my entire app inside Python, though I think I do have a colleague that is going to try embedding a Django app inside their Postgres database. I'm impressed by the idea. I'm also terrified of what may come of it. But let's take a really basic example. So over here, I've got, I just want to do some URL escaping. And so I'm going to run this right here. And it's nothing special, but I want to, do some URL escaping for my URLs before I maybe shove them in the database for some reason, right? I want to just do some sanitization. I'm going to pass this around as a parameter layer or something, and I want it to be sanitized. So great, but I don't have to do this necessarily in, Python every single time if I wanted to, right? So if I come over here to DataGrip and let's see here. And so I'm just going to create this function. I'm going to import from the standard library the quoting package, run this, and I've created that function now in here. Just a couple of seconds. Maybe just, there we go. Okay. And now if I want to go ahead and just run this, I can say, select URL quote. crunchydata.com. And just execute this directly in SQL. And I'm going to see this is all nice and escaped for me directly inside my Postgres database. I could actually, maybe if I wanted to do during my insert, right? I'm inserting into some table. I can actually pass it in this way and use that function. Really, really nice and handy. So simple, anything in the standard library, you could now start to put parts in here, right? You can pass in text, integer. You can actually pass in arrays that are going to map. And so we, when we launched Crunchy Bridge, I kind of had this discussion with myself of like, cool, let's put this in place and let's see what we can do with it. And I tweeted, I wonder what was possible. And I've always kind of loved recommendation engines. As soon as I get data, I love just piping them through to learn like what we can learn. Like ever since Netflix had the challenge of like, can you build a better recommendation? And there's a lot of basic models, and I'm not a data scientist at all, but you know, gone through a few books. I can build one up in Excel, build one up in Python, and to me, it's always a fun thing when you've got a lot of data. What can we go and analyze and learn from it and see if we can, you know, give a better user experience? So I went and found just a basic Python one with some code. I Googled, this is probably not the best one in the world. It could be better, but it was an excuse that I hadn't touched Pandas in probably a year, that it's like, okay, let me just see what we can do. And so here was the basic, I found this off some example and adapted it slightly. We were going to import Pandas. It had a couple of CSV files, which were absolutely perfect for me, right? So here, if I look, you've got order ID and product ID. These are all the historical orders. It's kind of, you know, denormalized, right? So you've got order ID 2 here, and you can see there were 3 products in the order. I've got my products over here, and if I want to look up the name, you know, the people that were most likely to order a baseball glove maybe also ordered a baseball bat, right? So from here, what we were going to do is load the orders for each product, then find all the relevant ones. So when you ordered this product, you also ordered these other ones. Find all the accompanying products, build out how many times that occurred, and then basically build this into a data frame right here, where we can have Pandas basically kind of sort and do the recommendations down here on a merge, right? So we're going to get the recommended ones, and then we're going to merge this with this other table to get the labels. And so this was going to output some kind of gnarly JSON thing for me. And I said, well, instead of me querying out to all the tables, can I do this directly inside my my Postgres database? And you can probably guess the answer is yes. I think I need to drop these tables really quickly. All right, and so now I don't have any tables right now. And so I'm going to create some tables that really clearly mimicked what we saw over here, right, from these CSVs. This could be a completely other format, but it's, you know, I'm taking something directly from Python and saying, let's put this in Postgres and see how it works. So, and presumably, right, you probably have your orders saved in a database. So, all right, I'm going to create the tables. I'm going to insert the orders, and I'm going to insert some products here. Perfect. And now what I'm going to do, so back over here, we created this function. We said the language was PL Python. We passed in some stuff, and then we basically started writing some Python in here. And so what I'm going to do is I started to gradually build this up. The exact same. Import pandas. So here, I'm actually passing in an array. So instead of parsing the CSV, which Pandas is really good at, I'm passing in 2 arrays from Postgres. Order IDs, an integer array, ordered products, an integer array, I'm basically building up kind of arrays that can build up those exact same order frames. So I'm going to build up a data frame of my orders here, and then do the exact same stuff. I'm going to find all my relevant orders. I'm going to find the number of accompanying products. I'm going to build up, get my recommendations back up here, and, via that data frame, I am going to pass in the product ID that's in the cart. So the idea, right, is I put a baseball glove in my cart, and now I want what other products I should recommend based on the baseball glove, right? And then I'm gonna return this as JSON actually inside the database. So I'm passing in a bunch of Postgres arrays. I'm going to return this as a JSON data type. It could be JSONB, but JSON's fine. And we're going to create this function now. And we're going to see if we can get some recommendations, which if demo works or fails, demo got to be with me. All right, there we go. Let's see what we got here. So we've got this pretty gnarly JSON right down here, but we can see if I expand it quite a bit.
You can double click on the field.
Let's see. Yeah, I think it still inlines the JSON, so I can scroll. There we go, there we go, and there we go. Now we've got the data over here. Because it's Pandas, we have a bunch of data frame data stuff before. But here's this JSON that I could go just parse out directly in Django or SQL Alchemy or whatever to say, like, here are the products you should recommend for a baseball glove. I don't know what these products are offhand, but like, actually, there we go. Cleats. Apparently football helmet's common, and a baseball. So for a baseball glove, you should recommend, a baseball, some cleats, and a football helmet. A few other tips. Oops, wrong one. So I would actually today go and rework some of this. So instead of passing in all of those arrays, so if I look back here one more time, you can see my table when we inserted it, it was unnormalized. Like I might actually go and say, I don't want to parse this as an array. Here I'm aggregating all of this as an array. So I'm getting the raw list of order IDs and letting Postgres do the heavy lifting of parsing that into array. It's going to do it all really, really fast. I might actually restructure my Postgres table for each order to have an array of the entire set, right? So instead of, look right back over here, instead of one of these, I might do something like this, right, inside my database. Makes a lot of sense that I don't have to go and join and aggregate this. The other piece is I'm passing all of this in. If I wanted to, I could actually do a plpy.execute here and pass in the query and run the query here. I could say select star from orders where ID equals, this passed in, order ID. So I could actually load it directly inside instead of building up all this to pass around the arrays. So definitely in some ways I could iterate and improve this a good little bit. I would try both approaches and benchmark the performance. My personal recommendation is, take this in Python and then step through piece by piece by piece. Debugging, you can basically trap and return errors from the PL Python SPI error and catch and return the exception as you're debugging step by step going through. I kind of flew through that example. The there's a step-by-step version of it live in this blog post. I think we can share a bunch of links after the talk, can't we? It's all recorded. If you Google for this, you'll probably find it. If you're looking at some further reading, we try to blog about a ton of this at Crunchy Data. If you're curious, like what you can do with Postgres. The Postgres docs I usually describe as reference docs. They're not great on how to do something. They don't go, here's a tutorial, but they're great reference docs. I actually think the PL Python docs are they're small, but shockingly good for everything you want to know. If you want to actually go and try this yourself, you can sign up on Crunchy Bridge, provision an instance. Hopefully that kind of whets your appetite to what you can do. It personally blew my mind, the idea, and I'm still back and forth. I'm like, is this brilliant or is this horrible? But there's so many use cases in between, right? I just want something from the Python standard library to parse a function in my database, right? Coming back to this basic one. Oh man, and if I don't have this in Postgres, it's in the Postgres standard library. Now Postgres just became even more powerful because everything in Python I can do directly in the database is a really quick function. All right, that's it. Wow. I think I covered a little bit there in a lot of time.
Covered a lot. Last two questions, and this is something that I think a lot of people trip up on. How do you specify the Python version inside of Postgres?
So you can't get super granular. There is PL Python and PL Python 3U. So I think it's PL Python U and PL Python 3U. So PL Python U is 2, PL Python 3U is 3. So they did do a split there. It's kind of up to you as the database maintainer or your infrastructure provider, right? So on Crunchy Bridge, we're patching that and updating it, right? And coordinating with you if you want to upgrade across kind of bigger versions. Generally, knock on wood, right? Like 2.x was pretty stable. You could go ahead to the next one for the most part. 3.x was such a bigger breaking change. There's a new PL Python for it. That's PL Python 3U. So make sure to pay attention whether you want 2.x, which I don't know why you would, or PL Python 3U. And if you show up on a database and it doesn't exist, to enable it, it's just create extension PL Python, I can spell it, 3U. Oops. So I've already got it enabled, but this would enable it if it's not there. And you may have to kind of white label the extension yourself. So it really depends on your setup. Like it doesn't work on RDS because they don't allow you to bring new extensions. We do on Crunchy Bridge. If you're running it yourself, you obviously have pretty full control there.
And the last question that we have is, what about the performance of the Python functions? I'm guessing looking at the function that you just ran, it was like what, 50 milliseconds? So I'm not guessing it's a lot.
It does depend on what you're doing, right? Like there's a little bit of kind of marshaling data from Postgres to Python. This is why in some cases I might recommend, right, doing the heavier lifting this way. I would try the couple of approaches. I haven't heavily performance tested this. It's more of a sample set. I would before putting it in production. And I would try it a few ways of, is it better for me to grab the array from Postgres and pass it into the function? Is it better for my function to go and grab all the data? But it's pretty manageable. I mean, if you think about it, there's no way this is going to be worse than you querying to Postgres and passing this all the way back out into your Python web server, doing the logic and feeding it back into Postgres. You've got a network round trip versus doing it local to the data. So yeah, there's some performance to it. But if you're doing this exact same functionality anyways, it's not going to be significantly worse because you're doing it.
It's not going to be significant, yeah.
Where the data resides, right?
Yep. Well, Craig, thank you so much for joining us. I'm sure we're going to have a lot of this information in our description and also share some of those, some of the code as well. So yeah, thank you very much. And,
yeah, thanks so much.
Thanks for coming over. All right then, everybody. See y'all later. Bye. Craig, are you still there?
I am.